Hi, today we're going to solve literal equations. And in general, that means that we are not going to necessarily have a numeric answer. We're going to have like variables in the answer. And it can be something as simple as a squared plus b squared is equal to c squared. Solve this for b. So I would subtract a squared and take the square root of both sides. And I would have my answer. So just making sure that you were thinking about this in the terms, this is not C minus A. Okay, so the square root does not take out the double squares whenever you're doing something. So don't do that in the end of working one of your problems. All right, I could have something like in fractions where I have 1 over A plus 1 over B is equal to 1 over C. There are a couple of ways that you could work that problem. If I said I'm going to solve this for C, I could look at the first part of it and add these fractions together, finding a common denominator. So B plus A over AB is equal to 1 over C. And then we know that I can rewrite fractions. If I flip one side, I could flip the other. So I can now flip the fractions to get AB over B plus A is equal to C. But another path that I could take to work this problem would be find a common denominator for all of it and clear the fractions, which would be taking 1 over A plus 1 over B plus 1 equals 1 over C and multiply by ABC, which would leave me BC plus AC equals AB. All right, so when I see that, now I see a C here and I see a C here. So I need to factor out the C. And then divide by what is with C. So C equals AB divided by B plus A, which was what I got over here. So I don't care what method that you use as long as it is mathematically sound method of doing something. All right, if I were to have M is equal to 2n plus 3 over n minus 4, 4n. So I look at this and I can see an n here and an n here. So somehow I'm going to have to get them all together. So multiply by the denominator. So that would give me m times n minus 4 equals 2n plus 3. Distribute out the m's. So mn minus 4n equals 2n plus 3. Now that's an n right there, sorry. Again, I'm looking for n, so I can see there's an n here and an n there. So I need to get those two things together. So I'm going to subtract and put them all on one side. So mn minus 2n minus 4m equals 3. So I need to isolate that. So this time I need to move this one So I need to isolate the variable I'm looking for. So mn minus 2n equals 4m plus 3. Now I can see my n's and factor them out. And divide by what comes with the n. So you would have n equals 4. Sorry, that did not come out nicely. N equals 4m plus 3 over m minus 2. Now I realize that it's possible to have worked that problem the other way. Okay, so I'm just gonna erase that part of what's going on. So if instead, when I'm here, whoa, thought that was an eraser. So instead of working the problem the way that I worked it before, it is possible that I could have said, all right, I'm moving so negative 4m equals 2n minus mn plus 3. Subtracting the 3 this time. And then factoring out the n. And then dividing by 2 minus m. And I would have n equals negative 4m minus 3 over 2 minus n. And that could be a way that you guys choose to do that. So if you think about it, they're the same. I could factor out from the second one, I could factor out a negative. So negative 4m plus 3 over negative n plus 2, so that the negatives would then cancel out and it would give me the same answer. So it doesn't matter to me which way you guys work that problem. You would still get the same answer. So that's really all there is to solving literal equations.